Hello friends, in the last lecture of the chapter thermodynamics, we have discussed about the thermal equilibrium, the heat, work done, internal energy. Also we have discussed about the zeroth law of thermodynamics, the first law of thermodynamics, also the thermal equilibrium, and also we have discussed about the PV diagram. Now today in this lecture we are going to discuss about the concept of the positive and the negative work, but with the help of PV diagram. Now here it's a cylinder and there is a gas inside the cylinder. The gas is enclosed inside the cylinder and the cylinder is fitted with a movable, massless and frictionless piston as we have discussed in our earlier lecture. So, such is the cylinder and the gas is enclosed inside the cylinder. Now, here on the y-axis, we are considering the pressure, the changes in the pressure. And on the x-axis, we are considering the changes in the volume of the gas of the system. Now, this is point 1. The system initially is at point 1. And with time, when the temperature is constant, it changes from 1 to it changes to 2. That is, initially when the system is in the state 1, the pressure is P1 and the volume is V1. Now the pressure is P1 and the volume is V1. Now, the gas inside the cylinder expands and it pushes the piston and the volume of the gas increases. So, the volume of the gas now increases. The piston is pushed in this direction. The system moves from the point 1 to the point 2. At point 2, the pressure, since there is increase in volume of the gas, there is decrease in pressure of the gas. So, the volume which was V1 now increases to volume V2 and the pressure which was P1 decreases to pressure P2 and the system of gas now comes at the point 2 where P2V2 is the pressure and volume of the system now. Now here the gas expands at constant temperature. The volume of the gas increases and the pressure of the gas decreases. Now, according to what we have discussed in our initial lectures, the work done, W, the work done by the gas, W, is initial volume V1 to final volume V2. We integrate all such dW to increase the volume of the gas. So, we know that dW is PdV. So, from Vi to Vf, PdV. All such PdV we integrate. So, the area under this curve. So, the area under this curve, the area under the isotherm. Because why should we say it an isotherm? Because the temperature is constant when the system changes from 1 to 2. So this area under the isotherm is the work done by the gas. Since the volume of the gas increases in this process, hence the work done by the gas is positive work done. Now we know that this is the pressure on the y-axis. On x-axis is the volume. So, P into dV, that is the pressure into the change in volume. we are integrating from V1 to V2 and all the steps we are adding. So this area V1, 1, 2, V2, this area is integral of Vi to V1 to V2 PdV. This is greater than 0, and the work done in such case when the volume of the gas increases is a positive work done. In the next case, we are going to discuss about the negative work with varying pressure with the help of the PV diagram. Now, there is a cylinder, a gas is enclosed inside the cylinder, and the cylinder is fitted with a piston which is movable, frictionless and massless piston. Now, in the second case, this piston is pushed inwards. Since the piston is pushed inwards, the gas is compressed. Its volume now decreases, and hence the pressure inside the cylinder increases. Now, we are going to discuss it with the help of the PV diagram. The temperature remaining constant. So, on the y-axis is the pressure of the gas, on the x-axis is the volume of the gas. The initial state of the gas is 1, where P1 is the initial pressure of the gas and V1 is the initial volume of the gas. The gas is at state 1. Now, the piston is pushed inwards. So, the gas is compressed. The system moves from 1 to 2. So, the volume now decreases from V1 to V2. The pressure increases from P1 to P2. The gas is compressed. At constant temperature, the volume decreases, the pressure increases. Work done. We know work done is equal to, according to the formula, integral of V initial, that is initial volume, to final volume, Vf, dW. That is, all such work done from Vi to Vf are added or integrated. So, integral of Vi to Vf, PdV, according to the formula. So, this P is the pressure and V is the volume. So, dV is the change in volume. Now, the work done is area under the isotherm. Area under this isotherm. Work done is area under the isotherm. So, how much is the work done? It is area under this isotherm, this much. This much area is the work done. Now, since in this case the volume decreases, dV is less than 0. Hence, the work done is a negative work. That is, the work is the area under the curve from V1 to V2, which is less than 0, because this dV is less than 0, and in this case negative work is done. We can discuss the examples of the positive and the negative work done by system as there is a milk and the milk is boiling. So when the milk starts boiling, it will expand in the container. So such expansion is a positive work done by the system. The next example which we consider is of a spring. The spring is compressed. So the work is done on the system. The work is done on the spring. The volume of the spring decreases, and the work done in this case is negative. In the third case, we are discussing about positive work with constant pressure. That is, when the pressure is remaining constant and the volume is increasing. The positive work done we are discussing. Now here again is the cylinder, and gas is enclosed inside a cylinder which is fitted with a movable, frictionless and massless piston. Now, on the y-axis is the pressure and the x-axis is the volume. Initial state of the system is 1. So the pressure is P1 V1. And now the pressure remains, or this is the pressure P. The initial state is the pressure is P and the volume is V1. And now the pressure remaining constant. The system, the gas pushes the piston. The volume of the gas increases because the piston is pushed in the outward direction, and hence the volume of the gas increases from 1 to 2. From V1 it increases to V2. So the volume of the gas changes from the Vi initial to Vf final. Now here it is not a curve because the pressure is not variable. The pressure is a constant pressure. So it is a line. It is not a curve. So this line is a straight line which is parallel to the volume axis because the pressure is remaining constant. Now the work done to increase the volume of gas or to change the state of the system from 1 to 2, the work done is the area underlying this straight line. So the work done. Now here, since it is a straight line, so we don't have to take the integral sign because the volume, the pressure is not changing. It is at constant pressure. So we directly write W is equal to P, that is the pressure of the gas which is remaining constant, Vf or V2, final volume, minus V1, that is Vi, that is the initial volume. So work done is P Vf minus Vi. If Vf is greater than Vi, final volume is greater than the initial volume, then the work done will be positive because this is positive. But if, which is like shown in this case, in the figure, in the graph, in the PV diagram. But if Vf, that is the final volume, is less than the initial volume, then the work done will be negative. And the next case, which is the case 4, which I want to discuss with you, is that if Vf minus Vi is 0, that is, there is no change in volume. There is no change in volume of the gas. That is, the gas molecules, there is no displacement of the gas molecules. Then in such a case, when there is no displacement of the gas molecules, there is no change in the volume of the gas, the work done by the gas will be 0. That is, we can conclude the work done by the gas at constant volume is 0. The next, we will discuss how the area under this PV curve has a dimension of work. So, we consider this quadrilateral A, B, C, D. So, area of the quadrilateral ABCD is the V2 minus V1, that is the change in volume of the gas, into the change in the pressure. So this is P minus 0. So this is, so the dimension of area is the dimension of volume into the dimension of pressure. So the dimension of this area will be now dimension of volume into dimension. Now we know pressure is force upon area. So dimension of pressure is dimension upon area. So dimension of volume is m to the power 0, L to the power 3, T to the power 0. Dimensions of force. Force, that is, its unit is Newton. So force is equal to, which is m to the power 1 kg meters per second square is the basic unit, or for Newton. So, kg meter per second square. This is the dimension for force upon area, that is m to the power 0, L to the power 2 and T to the power 0. So, we rearrange, we take here all the dimension m to the power 0 plus 1 minus 0, L to the power 3 plus 1 minus 2 and T to the power 0 minus 2 minus 0. So, we get here dimension for area, that is equal to m to the power 1, L to the power 3 plus 1 is 4 minus 2. So, L to the power 2 and T to the power minus 2. This is the same dimension of work. This same is the dimension of work. Hence, we say that this area under the curve or this line represents the work done. Thank you.